Hey everybody. Today we're solving equations involving fractions and rational expressions. Remember that a rational expression is just one polynomial divided by another, so really it's just a special sort of fraction. Here are the 4 problems we're going to do. They all use one big idea. In every case, we're going to find a common denominator and multiply the entire equation by that common denominator. This will clear out the denominators and leave us with just a polynomial equation that'll be much easier to solve. I think problem 1, which is the easiest of the 4, really illustrates this idea. X over 2 plus 3x over 5 equals 3. So the least common multiple of the two denominators, 2 and 5, is 10. So we're going to multiply all 3 pieces of our equation by 10. Now I'm going to have some cancellations. 10 times x over 2 is 5x, 10 times 3x over 5 is 6x, and of course 10 times 3 is 30. Now this is just a polynomial equation. I combine like terms, and I divide both sides by 11 to get the answer, 30/11ths. Problem 2. 2 over x minus 4 equals 1 over 6x. I have x's in the denominator now, but the process is exactly the same. I get the least common multiple for the denominators, 6x, and multiply every piece of my equation by that LCM. Then I cancel common factors between numerators and denominators and simplify. I get 12 minus 24x equals 1. Get the x's all alone by subtracting 11 from both sides. Subtracting 12 from both sides. And then divide by negative 24 to get the final answer. X is 11/24. By the way, notice that x equals 11/24 is a valid solution here. If I plug it back into my original equation, the denominator's never 0. Now, this is something that you always should check, as the next example will illustrate. 1 over x minus 2 equals 3 over x plus 2 minus 6x over x squared minus 4. First, we need a least common multiple for those 3 denominators. Now, x squared minus 4 is a difference of squares. It's equal to x minus 2 times x plus 2. So the least common multiple for these 3 rational expressions is just x minus 2 times x plus 2, the least common multiple for the denominators of them. So I multiply through by that LCM. That amounts to multiplying that LCM by each of the numerators. Now there's lots of common factors to cancel here. On the left-hand side, the x minus 2's cancel, and I'm left with x plus 2. For the first term on the right-hand side, the x plus 2's cancel, and I'm just left with 3 times x minus 2. And for the rightmost term, everything cancels except for the 6x. Now, I solve this by FOILing out the 3 times x minus 2, combining all the like terms, and dividing both sides by 4 here to get an answer of negative 2. So it seems like we're done here. We've got x equals negative 2. But there's a problem. When we plug x equals negative 2 back into our original equation, we get a 0 in the denominator. There on the first term on the right-hand side, 3 over x plus 2. So x equals negative 2 isn't really a solution. It's what we call an extraneous solution. When we cleared out the denominators by multiplying everything by x minus 2 times x plus 2, we expanded the domain of our equation, potentially allowing for x values that would solve the new equation, but not the original one. X equals negative 2 is in that category. It solved the polynomial equation that we got after clearing denominators, but does not work in the original problem. Since x equals negative 2 isn't really a solution, this problem actually has no solutions at all. Bottom line, when you're solving rational equations with variables in the denominator, you should always plug back in at the end to make sure that the answer you have is an actual solution, not an extraneous one. Let's do one more problem. 7 over 2x plus 1 minus 8x over 2x minus 1 equals negative 4. So the LCM is going to be 2x plus 1 times 2x minus 1. We multiply the entire equation by that. Let's do it a little faster this time since we've already done 3 examples. When I multiply the first rational expression by that, the 2x plus 1's cancel and I'm left with 7 times 2x minus 1. Similarly, when I multiply that LCM by 8x over 2x minus 1, the 2x minus 1's cancel. And when I multiply it by negative 4, well, I just get negative 4 times that LCM. I need to FOIL everything out, combine like terms, and solve the polynomial equation. On the left-hand side, I'm just distributing. On the right, I'm starting by doing 2x plus 1 times 2x minus 1. That gives me 4x squared minus 1. Combining like terms on the left, I get negative 16x squared plus 6x minus 7. And distributing the negative 4 on the right, I get negative 16x squared plus 4. I'm going to add 16x squared to both sides to cancel out those quadratic terms, and then add 7 to both sides. Overall, 6x equals 11, or x is 11/6. Practicing what I preach, I'm going to go and plug that back into my original equation to make sure that I'm never dividing by 0 when I do. In this case, the denominator does not turn out to be 0 in any case, and therefore x equals 11/6 is a legitimate solution to this problem.